Welcome to this third part. In a way that we will try to enhance what we have doing regarding to our queuing theory model, because we need to know how parts are queuing. So that's why we need to collect some statistics. So just to remember a little what we did. So we create our initial model, and that model was like this, in a way that parts were pulled from B1 and then push to B2, B3, B4, and then were pulled from those three buffer by M2. And then we got to realize that for some reason the only existing queue was the one regarded to B2. So for enhancing this, we try to add some additional variables in notation in a way that we could be able to quantify this, because we need to plan ahead all the models that we want to create, because eventually if things are going to change, we need to define proper key performance indicators, right, in order to validate the new version of our model. So the next question, right, is about what about if I know, right, if we know that there is a total cost regarding to the process's time per part, right? So imagine that the process time per minute in machine 1 is 300 pounds and in M2 is 200. So what about if I would like to know the total cost of this process, right? So how we could do that? Well, in the same way like we did before, we can add some extra variables, right? For instance, we could estimate the time that you spend in every machine, right, by creating additional attributes, right, and then at the same variable, right, we could update it either here or either here, right, because we are looking at the total cost. So we could have a variable that is called var total cost, which is equals to the same value plus the time, which is regarding to the cost that a part implies when they get processed in M1 or M2. So as you can see here, time minus attribute time in M1 is the total time that you spend in M1 times your cost for that time. See, so we will do it. So don't forget to save your model as a new version. So actually that's what we're going to do right now. So this is going to be our version 2. Like this. Right. So what we're going to do that we would like to add new elements, new variables. So for instance, we have a new attribute, which is the attribute time in. So in order to know exactly when the part arrived to M1, like here. So we want to define a new attribute. It's going to be a new attribute. So it's going to be attribute time in M1. And of course, we have the same one for M2. So M2. In addition to this, we have variables. We have var total cost and var cost M1, right? In here, we're going to place the value of the cost per minute in order to process a part in M1, and in var cost M2, the same thing, but for M2. So we have var total cost, like this. So we have this variable, cost, and this is a variable. And the second variable is the var cost of M1 and M2. Cost M1 and cost M2. Because those figures are normally constant, they're not going to change in this model, we can define their values immediately. So for instance, we can say that either here we can set their value, or what something that I really like to do is that we can initialize those figures at the beginning of the model. So in model, initialize actions, I will set that first value equals 2. We're going to our previous example. It's going to be 300 and 200. So 300 and the same one, but M2 is 200. And because maybe I won't remember what is that in the future, I could add some comments like this is the cost per minute in order to process a part in M1, and I can copy that. So you see that those comments are very useful, because later on when you want to check your model or do some modifications, and sometimes when you deal with many notations, it's very difficult then to remember all of them if you haven't been consistent with that. Of course that the name here is var cost M1, so it's linked to that, but eventually when you use too many names, you need to reduce them, so you start using codes, and those codes are very difficult to remember sometimes, unless you will be very aware of the model and using that all the time, but that's not what normally happens. So in here, so then we need to get the equations again. So in the actions on input of M1 here, just need to place in action on input that notation. I validate this. Action on output, all that means that I'm going to update the value of var total cost. So action on finish, yeah, when you finish the process. So to copy this here, so I need to a little. So what I'm doing here is that var total cost will be equals to its previous value in order to update that value, plus the difference in time, which is the total time that you spend in machine 1, which is also multiplied by the var cost in M1. Attribute time in is not defined. Let me see. Yeah, because I named it wrongly, you can see there. So witness will never allow me to make mistakes, which is very good. So let me change this a little. This is the name, just a mistake here. That one and this one. I really love when they have this kind of a software that help us to check almost everything. It's really good. So action finish. So now we can do that. Check this. Now it works perfectly. Fantastic. So I'm going to copy this, because I know that in M2 only going to change here M2. So in that way we can do this even faster. So let's just like this. So in here, in action on finish, in addition to all our statistics, right? All statistics, we can do something else. Maybe before doing anything else, we can do here. So cost, right? So for instance, we can do that. Okay. We know that we need to modify this regarding to M2. So here, right? And we know that at first in the action on input we have this, the same attribute which is collected the time, but now it's going to be regarded to M2. Exactly. So now I can also display the time that a part is spent in the system and in every single part. So for instance, I will have to add the cost, for instance, regarded to M1, for instance. sorry, I want to select the name. So I will try to use a different color just to differentiate them very well. We'll try to use maybe this green like this there, and it's not a very fancy color, but still it will make a difference. So from this I'm going to use maybe another color, something like this. Like that. And I'm going to change the font. Like that. Draw. So there's the cost, right, for this one. Cost there. I can also do the same for the cost of M2. So display the name like that, and to use again this green one just to make sure that for some reason when always talk about Muni, green looks like to be the most suitable color. That is strange, isn't it? But it's like that. So I'm going to leave that here just to make sure that we're talking about the same thing. So there. Actually, this is a total one, so I'm going to leave it even outside here, like that. This one is okay there. I'm going to also place the name, the value of that. So I'm going to use the same configuration, the same pattern. I'm going to maintain the consistency with the result when I will be trying to look in the model. So it's also very important. It's very important to once you create variables and then you display them, try to use the same color or same notation, because you will know what you were talking about just by seeing their color, right, or their format. See, so I know that there we will see the cost, and we could also see the total cost, how that evolves. So, which is this one. So we can display that one. Display name. Like that. I'm going to use a different color for this one. It's going to be red, because it is the grand total. So here we see more or less what this looks like. So I'm going to also display the value like that. So I'm going to use maybe this color blue. I'm going to use Times New Roman again, because we know that looks better, much better. And let me see. Maybe I would change the color. Maybe I would do that for the background, and the text is going to be yellow. Draw. Right. See? So there's no the figures. That is the grand total. So now, also, I can display this this var cost, right? Because this var cost is the cost for here. So this eventually should never change, right? What should be changing, right, is the this total cost. So if I run this model again, I'm going to save this model too, just make sure it is there. So I'm going to save this and I'm going to run it. See, figures are never changed. See, and this is the total cost by the moment. So every part contribute to the total cost of this. See, those figures don't change because they are constant. All the time var cost M1 is 300, and all the time var cost M2 is 200. But when they are going here or here, they are collecting their values in their attribute, and that's why I can calculate this different here, because either in M1 and M2 this figure is changing. But look, I have a problem with the figure. Look, some asterisks. So that means that I need to modify a little its format. So I can upgrade the graphic. Let me see if I can do this. So I can update the graphic like that. So for instance, the width, so to make it bigger. So update like that. So let's see what happens if we run the model now again. You see, so eventually that number could be bigger than used to be. We'll only simulate and you see, so now the number can be bigger. See, so now we added more features. We can know what is the total cost in processing all those parts in this time. So thank you for watching this third video, and after this we're going to introduce new formulas in order new functions really from witness, just to select the buffer regarding to some characteristics. Don't forget to save your model. Thanks.